Okay. Okay. So first thing, no silence, silence. As you all know, like Sri Lanka, we are all together. Is silence. Is not having a good time. I know that most of the students here like want to feel that in the same way, but because like being honest, even I'm in an area where only rain was there for the past few days and not to the past 2 3 days. Even though we saw all the floods and slides happening, and even in areas like Aturugiriya, Kalaniya, but I was not affected, but by any mean. So most of the students who have come to the class here and made the class made today, probably you haven't been affected, but there are students who are joining our online class from Nuwara and Ratnapura in those areas and Kandy. Some students even contacted me personally because I think you have seen it. I posted a post called this Yudukam. That is one thing that we can do from our end. Like I personally I did I can say few donations, but many donations. But as a practice, I don't publish them in social media. I have been practice that for a long time. Even though I do any donation, or let's say it's a like a scholarship or anything, as a practice, I don't publish it as like a social media post. But I'm not offended or I'm not against about people who are posting every small donation in social media. They have their right, but I don't do them as a practice. But one thing that additionally that I can do is like because there are some students from Nuwara, three students from Nuwara, and one student has sent a pic to one of our admins mentioning like, sir, this is our village, and the picture is only a ton of mud. So he has he has managed to send a photo. So this is our village. So then he have mentioned there used to be 70 families there, 70 houses. Out of the 70 houses, only 3 houses are remaining. The other 67 houses are vanished. Even they can't find that there was a house there. And somehow their family, none was like dead in that area that he told, because all the families were taken to the temple and a mosque in that area. So none of them has like passed away, but they have to start from zero. So there are so many families and students affected. So what I want to say, like even there might be not in those areas. Let's say you are from Maturugiri, you are from Kalaniya, the Mull area, when your father used to have a shop. Because of this flood, and it's all gone, so you have to start from zero. Like talk to our numbers, like me, and not only me, I saw that many tutors have put that post. We are ready to help you till the end of the exam. And even this is valid for any student who is willing to do maths in 2028. And I can take the responsibility in terms of combined maths. And this is not a thing that we will be doing, okay, after 2 3 months, now it's okay, no any floods, no any water, no any landslides, now we all are safe. So then you can pay, no, nothing like that. If I say, I mean it. So this is valid till the for your class till end of 2027. So if you're affected severely financially, you can talk to our admins and get a free access. And even though, let's say, like, I haven't mentioned this in the English medium class, but I don't think that doing English medium means that you are financially good. Salli තියෙන එකට English medium කරනවා, not like that even. I did English medium, but not because of floods. If you're having any financial issues, you can speak to our admins. And if you are a physical class student, you can directly approach me and talk to me and ask for a free card. I don't think that whether I have mentioned this in the English medium class, but I'm always okay to give a free card to a student who is really having financial issues, because I'm a student who have received two free cards out of the three classes I used to go in tuition. Well, like I used to go for tuition, the three tuition classes. I'm a student who received two free cards. So then I know how valuable is that. So even though the reason is not because of these floods or landslides, if you are having a financial issue, your family is facing a financial issue, that it's hard to manage your tuition fees, because normally when you're doing English medium, the minimum for all three subjects will be around 15,000, maybe more. So if your parents are hard to afford that, you can talk to me. If you're a physical class student, if you're an online class student, you can talk to the admins. So if you're an online class student, they might ask for this Grama Seva certificate mentioning like as a clarification. But if it is a physical class student, I'll be asking the parents to call me, not like the parents should come here and talk to me. You can just ask your mother or father to call me, not me, one of my admins. So then we can give that free access. So as a country, that is one thing that I want to say. And if you know any affected families, just let us know. We can help in our level best. Okay, I know, but we don't feel that much because there's thing that unless the problem is yours, you don't feel it in the same way. අර ප්‍රශ්නේ අපේ වෙන තාක්කල් අපිට ඒක එච්චර දැනෙන්නේ නැහැ. So you might see it on the TV, but you don't feel it. So luckily we all are safe here. And one lucky thing that somehow your parents have built houses where there is no any risk from natural disasters, because tsunami came, these areas was not affected. Floods came 2016, and these areas were not affected. So you are lucky that your parents have built the houses in an area that is a risk-free area. And Sri Lanka is not a country that is prone to earthquakes, because we are not in between two plates. No, we are in the same plate. So happening an earthquake is very rare in Sri Lanka. So we all are lucky from that end. But if anyone is suffering, what I want to say, the thing that I mentioned, you can talk to our admins, and not only from that one. Let's say that you need some aid, you need some donations, anything, you can talk, and we can contact and do. Let's see what we can do. Okay, okay. So we all are here. So we are in the last day of vectors. Last week we did the vector dot product, or the scalar product between two vectors, the vector dot product or the scalar product between two vectors. So I'll quickly remind this. So what is the dot product? The dot product between two vectors is defined in this way. We have A, B, and this is theta. The dot product between these two vectors is defined as A dot B. This is equal to modulus A modulus B cos theta. So this is what we discussed last week in the last 1.5 hours. So let's do the remaining past papers and complete the work. And we learned about these unit vectors I and J. So when we discussed that I dot I is equal to 1, and even I dot J is equal to, J dot J is equal to 1. But since I and J are perpendicular vectors, I dot I was equal to 0. And I told you, when two vectors are perpendicular to each other, it's A dot B is equal to 0. When two vectors are perpendicular to each other, we say that the dot product is equal to 0. And if you consider the dot product of the same vector, A dot A, it's equal to the modulus squared of that vector. So here even the same thing, I dot I is equal to modulus I squared. So modulus I is equal to 1. That's why this becomes 1. So when we have A dot A, that is equal to modulus A squared. Okay. So let's start away past paper directly. Start the 2018 past paper, question number 20. Question number 20. We have done the first part, but that's okay. You can start from the beginning. Start the past paper. 2018, question number 20. You can start from the beginning. We have done this part, the collinear part, but do from the beginning. Now stop talking, do the work. 2018, question number 20. Okay, I'll start the question because this is a question that we have done before the previous part, the initial part, sorry. The triangle OAB, where OA is equal to A vector and OB is equal to B. E is the midpoint of AB. Okay, this is the midpoint of AB, and D is the midpoint of AB, and E is the midpoint of OD. We have the midpoint, this one as E. And they have given that F lies on OA. F lies on OA such that OF to FA is 1 is to 2. So this ratio is 1 is to 2. The two vectors that they have given is vector B and vector A. So we know these two are the midpoints. These two are the midpoints. Okay, first thing, find the vectors BE and BF. So how to find BF? BF is okay because you can easily find the vector BF either using these position vectors. You can remember we can write this as OF minus OB. No? When they are in terms of position vectors, you can write this in terms of position vectors OF minus OB. And OF is 1/3 of OA. This is 1/3 of OA. And OB is B. So you can easily find this BF vector, what we have done before. It's equal to 1 over 3A minus B. So you can pull out a 1 over 3 and keep this in this way. Okay, what is the vector BF? What is the vector BF? BF is equal to 1/3 A minus 3B. Then how to find BE? Okay, you can find BE as BO plus OE. So here I have considered the triangle BOF. And here I'm going to consider the triangle BOE. The triangle BOE. And then when you put this vector addition, you can write BE is equal to the right hand side position vector minus left hand side position vector. So that's the same thing. BE is BO plus OE. No, this BO is minus OB. Same thing. And then what is OE? It's half of OD because E is the midpoint. It's half of OD minus B. So I'm in the path of finding BE, and OE can be written as half OD. And what is OD? OD is OA plus AD. No? Then I'll find OD separately and substitute here. So what is OD? It's OA plus AD. OA plus AD. What is OA? It's A. AD is half of AB. And I know how to write AB. AB is equal to minus A plus B. It's equal to minus A plus B. So if you take a half out, OD is equal to 2A minus A plus B. The position vector of D, it's equal to half A plus B. So what did I do here? I was in the path of finding BE. And then I got it's equal to half OD. So I have simplified OD separately. I have simplified OD separately. OD separately. And then you can get the answer. What is BE? BE is equal to half into OD. What is OD? That's even half A plus B minus B. So this is 1 over 4. If you pull out 1 over 4, you get A plus B, and this is minus 4B. So which gives you BE is equal to 1 over 4 A minus 3B. A minus 3B. Now it's clear. You wanted to get BF and BE, you have taken both in terms of A and B. So when you look at this, it's clear. It's like the same thing. No, we have A minus 3B and A minus 3B. Then we are supposed to show that BEF is collinear. To find that, we need to show that these two vectors are parallel. So how can you show that the two vectors are parallel? If you can show the two vectors are dependent, okay, then you can show that the vectors are parallel. That means I'm going to write this vector in terms of this. How can I do this? Look at this. BE is equal to 1 over 4. This is 1 over 3. No? So we have done this before. This is 1 over 3. So what am I doing here? I'm bringing this 1 over 3. So I have brought this 1 over 3. The reason that I have brought this 1 over 3, then I know this vector can be written as BF. It's BF. But just writing this 1 over 3 is mathematically wrong. So what can I do here? To take out the impact, I'm multiplying this by 3. So basically multiply by 3 and divide by 3. No any impact. So this is vector BF. This is vector BF. Okay, then I have vector BE is equal to 3/4 of vector BF, which means the vectors are parallel. No, you can say that the two vectors are parallel because it's dependent. One vector has been written in terms of the other vector. A vector BE is parallel to vector BF. So when the two vectors are parallel, look at this. BE and BF are parallel. That means B, comma EF are collinear. Are collinear. So that is the first part. And then how did I say that these vectors are parallel? Because this means that BE and BF are dependent. If you can express one vector in terms of the other vector, that means those vectors are dependent. Okay. And then to get the ratio, I told you to consider the modulus. BE is equal to 3/4 of BF. No? So now when you consider the modulus BE is equal to 3/4 of modulus BF. Then BE is equal to 3 over 4 BF. BE is equal to 3 over 4 BF, which means you can get the ratio BE to BF ratio is equal to 3 over 4. So what are we supposed to find? The ratio between BE to EF. Okay. So we have the ratios. If BE is equal to 3, if this ratio is equal to 3, the entire one is 4. If this one is 3, the entire one is 4, which means this one is 1. So when you consider that this is 3, the entire BF is 4, then this is 3 is to 1, then you can write the ratio of BE to EF is equal to 3 is to 1. So this part we have done before. This part. Okay, so then let's see what is the additional part we need to find. Find the scalar product BF DF. BF DF. Yeah. Find the scalar product BF and DF. Okay. In terms of modulus A and modulus B. Show that if this is equal to this, both of them are perpendicular. Okay, now look at this. First find vector DF. First find the vector DF, this vector that they're asking, DF. Vector DF and BF. BF. Okay. So first find vector DF. How can I find vector DF? DF is equal to, we know OD, you know. We now know OD, so you can easily find DF in this way. Look at this. First find vector DF, it's equal to OF minus OD. So why did I take this path? Because we know OF is 1/3 of OA, and we have already found this OD. What is OD? It's half A plus B. So this is 1 over 3a minus half a plus b. First find the vector df. Okay. So how you can simplify this when you take the common denominator. The common denominator is 6. So this is 2a minus 3 times a plus b. Then I have vector df is equal to 2a minus 3a minus 3b over 6. So df is equal to minus a over 6 minus 3 over b, which means this is equal to, if you take out minus 1 over 6, a plus 3b. So first I want you to find df. Okay, so we have vector df. So they are asking us to consider the vector the vector dot product between df and bf, no? bf and df. Consider bf dot df. Okay, now write this vector addition and see what you get. Simplify this one. Do this alone. bf dot df. What is bf? bf is 1/3 a minus 3b, and df is minus 1 over 6 a plus 3b. Now what I want you to do is, when you multiply the two scalars, you get 1 over 18 a minus 3b dot a plus 3b. We can now consider the vector addition vector product between these two and simplify this. So I'll stop from here, and I need you to consider the vector dot product between these two vectors and simplify it and see what you get. See what you get. So the two scalars multiply. Here the two scalars multiply 1 over 3 into minus 1 over 6. The dot product is only between the two vectors. Silence, do this. I've given this, consider the dot product between these two. Okay, so if you consider the dot product, what happens here? We have minus 1 over 18 and a dot a plus 3 times this gives you a dot b. This is minus 3 times b dot a. Minus 3 into plus 3 is 9 b dot b. b dot b. So here a dot b and b dot a is equal, so it cancel off. I told you the vector dot product is commutative, which means a dot b is equal to b dot a. And I just mentioned a dot a is not 1. I dot I, those are unit vectors, that is 1. So what is a dot a? It's modulus a squared. What is b dot b? That is modulus b squared. So you're supposed to find this vector dot product in terms of modulus a and modulus b. So 1 over 18, you have modulus a squared minus 9 times modulus b squared. That's all. You can put this minus inside and then change these two, but that is not necessary. You have been asked to find the vector dot product bf and df in terms of modulus a and modulus b. So that part you have done. One thing you can do, you can send this minus inside and change these two, but it's not compulsory. Okay, now look at this. What is the remaining part of the question? If modulus A is equal to 3 times modulus B. Okay, now look at this. If modulus A is equal to 3 times modulus B, that means when you square this, you get modulus A squared is equal to 9 times modulus B squared. Okay, so if this one happens, We have this. So then the dot product between these two, now look at this. So this is the vector dot product. No? So they have given a condition if this is equal to this. Then I get modulus a squared is equal to 9 times modulus b, which means this is 0 because these two are equal. This and this is equal, which means this is 0. Then I get the dot product between two vectors, the dot product between the two vectors a, bf and df is equal to 0. So tell me, when the dot product between two vectors is equal to 0, what can you say about the two vectors? It's perpendicular. So that's the remaining part of the question. If modulus A equals 3 times modulus B, okay, then I get vector BF and DF are perpendicular. Are perpendicular. So that's how we use this. So this is the condition. If modulus A equals 3 times modulus B, we get the vector product is equal to 0. When the vector product between two vector dot product between two vectors is 0, that means the two vectors are perpendicular. So there's another way that you can even do this in the other side. I have told you, if you have been given, if A equals B, show that B equals C, you can do in the opposite way. I have mentioned that. If they have given A equals B, show that B equals C, you can consider, okay, let's see that B equals C and then get A equals B. But the most appropriate method is this one. But even you can do this in this way. How? I'm considering the opposite. If BF is perpendicular to DF, if BF is perpendicular to DF, then I know if two vectors are perpendicular, if two vectors are perpendicular, that means the vector dot product is equal to 0. So consider the vector dot product minus 1 over 18 modulus A squared minus 9 modulus B squared. This is equal to this. Modulus A squared is equal to 9 times modulus B squared. So when you consider the square root, you get modulus A equals 3 times modulus B. The most appropriate method is this one because they have asked, if this happens, show that the two vectors are perpendicular. But let's say in case that you won't be getting the idea of this one, then you can even follow this method. I have taken this as the if, and I have proved that modulus A is equal to modulus 3 times modulus B. Clear? Okay. Okay, then start this one, 2019 A levels. Question question number 22, 2019 A levels. So these are two different methods. This is method 1. And this is method 2. Start 2019 A levels. Question number 22. Silence, start the question 2019. If there's anything you want to ask from me, you can ask now when I come. And if there's anything the online students want to ask, you can send a message in the chat. Silence, do the work. The initial parts, like everyone should be able to do, especially getting this equation. Because it's only finding two vectors OC and BD. and then considering the dot product is equal to 0. That's all. Okay, so first thing, now keep doing the work. OACB is a parallelogram and D is a point on AC. So we have OACB as the parallelogram OACB. D lies on AC in a way that AD to DC is 2 is to 1. AD to DC is equal to 2 is to 1. What else? And then the two vectors they have given is vector B and vector A. The position vector of A or OA has been given as lambda A. OB is given as B. So this one they have given in terms of lambda. And then find vectors OC and BD in terms of AB and lambda. You need to find the two vectors BD and OC. So finding OC is quite easy because we can directly apply the vector parallelogram law. So when you apply the vector parallelogram law, you can directly say that OC is equal to the addition of these two vectors. So OC is equal to lambda A plus B. Vector parallelogram, or you can apply vector addition to this OAC. And then to find BD, the vector BD is equal to BC plus CD is equal to BC plus CD. And I know BC is even lambda A. CD is 1/3 of CA, no? CD is 1/3 of CA. So what is CA? What is CA? Then vector BD is equal to lambda A plus CA. What is CA? It's in the opposite direction. It's minus B. CA is in this direction. It's minus B. Then I have vector BD is equal, if you take out this 1 over 3, you get 3 lambda A minus B. If you take this 1 over 3 out, it's 3 lambda A minus B. So now I have the two vectors. This is vector OC and this is vector BD. Okay, then they have asked to cut. No, they have given the two vectors are perpendicular. So given that the two vectors are perpendicular, OC and BD are perpendicular. So when the two vectors are perpendicular, I know the vector dot product is equal to 0. You can consider that. The two vectors are perpendicular. Okay, now consider the vector dot product. OC is lambda A plus B. BD is 1 over 3, 3 lambda A minus B. So you can multiply by 3 and take it out. So it's lambda A plus B, 3 lambda A minus B. Now consider the dot product. 3 lambda into lambda is 3 lambda squared. A dot A minus lambda A dot B plus 3 lambda A dot B minus B dot B is equal to 0. Yeah. So then I know this A dot A is equal to modulus A squared and B dot B is equal to modulus B squared. So then 3 lambda squared modulus a squared minus lambda a dot b. 3 lambda means 2 times lambda a dot b minus lambda 3 lambda minus modulus b squared is equal to 0. Modulus b squared is equal to 0. Clear? So we get that equation. This is equal to this. Okay, hands up who got this answer. This. Okay, even in the online class, students send me a message if you have taken the answer. I mean this equation. Okay, find the value. Find the value of lambda if a modulus a is equal to b and AOB is equal to 5 by 3. Now look at this. They have given the angle between these two vectors. Now look at this. Look at the board. They have given the angle between the two vectors. So here we have considered the dot product between the two vectors. Now look at this carefully. We have considered the dot product between the two vectors. But I haven't considered the definition of dot product. What is the definition of A? What is the definition of A dot B? Tell me what is the definition of A dot B? Modulus A, modulus B, cos theta, where theta is the angle between the two vectors. So here I have considered the vector dot product, but not the definition. Because this is not the definition. You know the definition is equal to modulus this, and the angle. So here I have considered the dot product, but not the definition. So keep this in mind. When they have given the angle between two vectors, okay, listen this. When they have given the angle between two vectors, the only way that you can use that data, the only way that you can use this data is to consider the definition of the vector dot product. That is the only possible way. That is the only possible way that you can use this angle. So keep in mind, when they have given an angle between two vectors, you need to write the definition between the two vectors, the definition of the vector dot product between the two vectors. So since the angle has been given, I'm considering this one. Let's consider the dot product between OA dot OB. The angle has been given. This is equal to modulus A modulus B cos the angle is pi by 3. Then what is what is A? That is lambda A dot B is equal to lambda A modulus modulus B, and cos 60 is half. So it's clear. You get this lambda times A dot B is equal to, you can pull out a lambda times modulus A modulus B into half. Lambda cancel off. A dot B is equal, there's another data that you can use. They have given modulus A is equal to modulus B. So they have given that. A modulus A is equal to modulus B. So then you can write this in this way. Modulus A, and I'm writing this B even as modulus A. Which means I'm getting a data that A dot B is equal to modulus A squared over 2. So they have given this angle between the two vectors. So I have considered the definition of the dot product. So I'll give that as a point. When they have given an angle, always keep in mind, to use that data, you need to consider the definition between the definition of the dot product between the two vectors. Okay, now look at this. I'm going to substitute the second one in the first one. I'm going to substitute the second one from the first one. Sorry, the second one to the first one. I have 3 times lambda squared modulus A squared plus 2 lambda into what is a dot b, that is modulus a squared over 2 minus modulus b squared, minus modulus b squared, minus modulus b squared. So again a data that I know that modulus a and modulus b are equal. Modulus a and modulus b are equal. That's why even this one has been written in modulus a. Okay, now look at this. 3 lambda squared modulus a squared plus lambda times modulus a squared minus this one can be written as even modulus a squared. So it's clear that you can see modulus a squared cancel off. 3 lambda squared plus lambda minus 1 equals 0. I'm getting a quadratic equation of lambda. I'm getting a quadratic equation of lambda. Check whether there are factors, but there are no any factors here. No any factors. So then consider this lambda is equal minus 1 plus or minus this we discussed last week even. We discussed this last week. No, minus b plus or minus b square. I can remember. Matake. We had the class. We didn't miss a class. No, even last Tuesday we had the classes. So I discussed about, not discuss, we reminded you about taking the solutions of a quadratic equation. Minus b plus or minus a b squared, which is 1 squared minus 4 into 3 into c minus 1 over 2 into 3. So lambda is equal to minus 1 plus or minus 1 plus 12 square root over 6 root 13 over 6. So we have two answers, minus lambda minus root 13 over 6 or lambda equals minus 1 plus root 13 over 6. But lambda has been given that lambda is positive. Because lambda is positive, we can't accept this answer. So what is the only answer? Is lambda equals root 13 minus 1 over 6. Root 13 minus 1 over 6. Clear? Okay. So you have come up to this one. Then before moving on to this one, if you have already done this good, put a red star mark and write in this way. Put a red star mark and write in this way. Write in a red pen. Red star mark and write in a red pen. If the angle between two vectors, if the angle between two vectors has been given, has been given, has been given, to use this data, to use this data, to use this data, we need to consider, we need to consider, we need to consider the definition of dot product, the definition of dot product, definition of dot product between the two vectors, between the two vectors. Okay, okay, then do this here. It's not lambda bar. I have cancelled this lambda and this lambda. It's not lambda bar. Because if you have got this one, I ask you to send me a message. Only 3 has sent. Complete the work. Just do this. Consider the vector dot product definition. So this is the definition for the vector dot product. Definition of vector dot product. We get two answers. So this solution of a quadratic equation that I have even explained last week. So after completing this, then start 2016. Start the 2016 question number 15. After this one, start 2016, question number 15. Okay, so first thing is find modulus A and modulus B. So you can remember when the vectors are in terms of I and j, what is the modulus? It's the square of this plus square of the square root. So it's 3 squared plus 4 squared square root. So A is equal to 5. Modulus A is equal to 5. And similarly, modulus B is 4 squared plus 3 squared square root. So modulus B is even equal to 5. So we have modulus A and modulus B both equal to 5. And then the next one, find A dot C and B dot C. Find A dot C and B dot C. So just write what is A dot C. It's equal to, now they have given find A dot C and B dot C in terms of alpha. Okay, then this is 3i plus 4j dot alpha I plus 1 minus alpha j. So I told you when you're multiplying these two, there's no use of multiplying I dot j because I dot j is 0. So only consider I dot I and j dot j, which is equal to 1. Then I have A dot C is equal to 3 alpha I dot I and 4 times 1 minus alpha j dot j. There's no use of multiplying I dot j because it's 0. Okay, I dot I, that I know it's 1. And j dot j, that even I know it's 1. So then I have A dot C is equal to 3 alpha plus 4 minus 4 alpha. So A dot C is equal to 4 minus alpha. Similarly, get B dot C. B dot C, it's equal to 4i plus 3j dot alpha I plus 1 minus alpha j. And now when you multiply this, 4 alpha I dot I 3 times alpha 1 minus alpha j dot j. So again, these two are 1. So I have skipped I dot j and j dot I, which means B dot C is equal to 4 alpha plus 3 minus 3 alpha. So B dot C is equal to alpha plus 3. Got it. Okay, hands up who have got these small answers. 5, 5, 4 minus alpha, alpha plus 3. Got it? No? Okay. Then now look at this. Now comes the angle. They have given, show that alpha equals half. If the angle between A and C is equal to the angle between B and C. Show that alpha is equal to half if the angle between A and C is equal to the angle between B and C. So I told you, if they have given an angle as a data, if they have given an angle as a data, what we have to do is we have to consider the definition between the vector dot product. So if they have given, let's say, the angle between A and C as alpha, then what can you write? You can write A dot C is equal to modulus A modulus C cos alpha. A dot C, we got the answer. It's 4 minus alpha is equal, modulus A is 5 times modulus C cos alpha. So if I take this as the first one, and now they have given the angle between B and C is even equal to alpha. So if they have given the angle, consider the dot product, the definition of the dot product. Same thing that what I have written in a red pen previously. This is alpha plus 3. It's 5 modulus C and cos alpha. So what can you say about these two when you consider the right hand side? It's the same, no? 5 times modulus C cos alpha. 5 times modulus C cos alpha. Then you can say that A is 1, the first one is equal to the second one. So then we have 4 minus alpha is equal to alpha plus 3. 4 minus 3 is equal to alpha plus alpha. So 2 alpha is equal to 1 and alpha is equal to half. Clear? Alpha is equal to half. Small thing, when they have given the angle as a data, consider the definition of the dot product. Consider the definition of the dot product. Okay. Okay, then let's do this one. Do 2017, question number 18. Hands up who got this one, who got alpha equals half. Madhya, like, there are some. Okay, start the next question. 2017 A levels, question number 18. And online students, send me a message if you have taken the answer. 2017, question number 18. And I don't have to mention like question by question when I ask from the physical class, hands up who have got the answer. Even online students, because today like there are considerable amount of number in the online class. Send a message mentioning got the answer, okay? And if you have any doubts, you can ask from me. So make sure when I ask the question from the physical class, you even send me a response. So that's easier. Then I don't have to specify and ask online students who got the answer. Start the next question. 2017, question number 18. 2017, question number. Silence, silence, silence. Do the question. 2017, question number 18. Oh, first thing, they have given the position vectors of O A as A and OB as B. And even OC, the position vector of OC in terms of A and B, it's 1 minus lambda A plus lambda B. So these are the given data and position vectors. And express the vectors AC and CB. So this part is the easy part. Everyone should be able to do this. AC is equal to OC minus OA because those are in terms of position vectors. 1 minus lambda A plus lambda B minus OA is A. This gives you A minus lambda A plus lambda B minus A. So then it is clear A and A cancel off. Then vector AC is equal to, if you pull out a lambda, it's B minus A. It's B minus A. And then what is CB? CB is equal to OB minus OC. B minus, what is OC? 1 minus lambda A plus lambda B. So it's B minus 1 minus lambda A, minus lambda B. Now look at this. If you consider the coefficient of B, that is 1 minus lambda B minus 1 minus lambda A. So it's clear you can take out 1 minus lambda from CB, which gives you B minus A. B minus A. Okay, so here now they are asking to show that the point C lies on the line segment AB such that AC to CB is equal to this. Okay, now tell me what is the meaning of this? Show that point C lies on the line segment AB. Point C lies on the, listen. Ahand. Tamil spelling, I don't know Ahand. How to say Ahand in Tamil? What? Okay, next time I'll tell you. Dhamma ki no Okay, so listen. Na? Hey, Kalunga. Okay, so this one, tell me what is the meaning of show that point C lies on AB. What is the indirect meaning of that? In terms of vectors, in what we have learned in vectors, show that point C lies on AB. That is the indirect way that they can ask to show that A, C, and B are collinear. Because if A, C, and B are collinear, that means this C lies on AB. So how can you do this? Look at this. Now it's clear in terms of vectors. So this lambda A 1 minus lambda, like scalars, no, constants. No? So in terms of vectors, even we have B minus A. Even here we got B minus A. Okay, now what I want you to do is write one vector in terms of the other one. So I'll do this in this way. AC is equal to lambda B minus A. I'm going to introduce this. So you can start from here. It's much easier. Let's start from here. I'm writing CB is equal to, I'm taking out this 1 minus lambda. Those are constants. And I'm introducing a lambda with a reason. I'm introducing a lambda. So I'm dividing a lambda and multiplying a lambda because I know if I write this in this way, lambda times B minus A is equal to AC. I told you my intention is to show that this is collinear. How can I show that these all the 3 points are collinear? If you can show that the 3 vectors are parallel, then good. Then all good. To show that the vectors are parallel, you need to show that they are dependent, which means you have to express one vector in terms of the other vector. So I have CB, vector CB is equal to 1 minus lambda over lambda times vector AC, which means the 2 vectors are parallel. AC is parallel to CB. The reason one vector has been expressed in terms of the other vector, so dependent vectors. Therefore, you can say that A, C, and B are collinear. Then you can say in this way, C lies on AB. You can say that C lies on AB. So C lies on AB is another way to say that A, C, B are collinear. A, C, B are collinear. Clear? A, C, B are collinear. Okay. Then get the ratio in using this one. So the ratio is CB is equal to 1 minus lambda over lambda AC. So if you consider modulus wise, only consider the modulus of the vector, keep them away because those are scalars. Okay, then I have CB is equal to 1 minus lambda over lambda AC. Then if you take this to this side, you get lambda over 1 minus lambda is equal to AC over CB. Clear? No? Take this here, which means you can say that the ratio AC to CB, the ratio AC to CB. So I have taken CB here, lambda here, 1 cross multiplication is equal lambda to 1 minus lambda. AC to CB equals lambda to 1 minus lambda. Got it? Okay, complete the work and think how you can get the next one. So always when we are going with the modulus is only for the vectors, because these are constants. You can keep them away. You can keep them away. Lambda, sorry, the modulus are for the vectors. And then I cross multiply, CB is taken to here, lambda here, 1 minus lambda here. Okay, now look at the next one. Okay, so now what they have given, this OC bisects the angle AOB, no? Yeah. OC bisects the angle AOB. Okay, now look at this. If you draw this AOB, so previously we have taken that C lies on AB that we have taken. And now they have given the C, the point C bisects this angle, the angle AOB. So what you can do is you can take this in this way, take the two angles theta and theta. Okay, now listen this. Now we know the angle between the vectors. No, we know the angle between the vectors. Okay. Okay, now look at this. If you write A dot C here, what is A dot C? Modulus A, modulus C, and cos theta. Okay. Now, in the expression that you're supposed to show, look at this A dot C. They have given that A dot C not only in A dot C, they have considered another one here. No, what is that? Look at the answer. Modulus B. Modulus B. So when you multiply this by modulus B, you get A dot C. Multiply this by modulus B, it's modulus B, modulus A, and modulus C. So small thing, what I have done here, I have multiplied both sides by modulus B. So I have multiplied both sides by modulus B, which gives me modulus B is equal to, sorry, A dot C is equal to this. Okay, now I want you to do this one. Do the same thing. Consider, this is B, consider B dot C and multiply by the modulus that they have given and see what do you get in that case. Do it. So first do this one and then write B dot C, because I told you when they have given the angle, you need to think by the definition. Same thing. When they have given the angle between two vectors, or they have given a data related to the angle between the two vectors, think from the definition. Think from the definition. So I have written A dot C. Similarly, write B dot C and multiply it by modulus A and see what do you get. And see what do you get there. Do the same thing. Consider B dot C and multiply it by modulus A. So I told you if they have given a data between the, sorry, if they have given the angle between two vectors, O, they have given, sorry, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vectors, O, they have given the angle between two vect a data related to the angle between the two vectors. You have to go with the definition. You have to go with the definition. Okay, so what do you get when you write B dot C? B dot C is equal to modulus B modulus C cos theta. And this one you need to multiply by modulus A. You need to multiply by modulus A, which gives you a modulus A times B dot C. Modulus A times B dot C is equal to modulus A modulus B modulus C cos theta. Okay, now tell me, so what did I do here? Small thing, same thing, small thing. They have given a data related to the angles. So I have just considered the definition. So that's all. I have just considered the definition. After writing the definition, it's clear they are asking something this modulus B into A dot C. So I have multiplied by modulus B. And then after writing this, they have asked something related to modulus A into B dot C. So I have multiplied by modulus A. Now tell me, what can you say about the two right hand sides? Modulus A, modulus B, modulus C, cos theta, modulus A, modulus B, modulus C, cos theta. What can you say about the two right hand sides? Equal. So the first one and the second one is equal, which means I get B modulus B A dot C is equal to modulus A B dot C. So I have considered the definition and I have got this answer. Clear? Okay. And now what I want you to do is consider the dot product. So we have written the definition. So what is the dot product between these two? It's vector A dot vector C. Okay, what is vector C? It's 1 minus lambda A plus lambda B. Consider the dot product between these two. Yeah, consider the dot product between these two is equal to modulus A modulus B dot, what is C? 1 minus lambda A plus lambda B. Simplify and see what do you get. Do this alone. Now do the simplification alone. So here I have considered the dot product A and this is C. So here it's nothing new. This is vector C. B dot, this is vector C. Okay, simplify and see what do you get here. Do this alone. Simplify and see what do you get here. You have to find lambda. Simplify this and you need to find lambda. Simplify and subject lambda. So here A dot A is not equal to 1. A dot A, B dot B are not equal to 1 because those are not unit vectors. So you find like simplify these and subject lambda, that's all. So do this alone. And if there's anything unclear, you can ask from me and continue the work. So multiply this. First multiply what is inside the square brackets and then multiply it by the outside modulus and see what you get as the final answer. Simplify properly, you're supposed to get a clean answer in terms of, I think, modulus A and modulus B. Let's see what do you get when you simplify this. No, do it slowly, silence, silence. So here, silence, modulus B and When you multiply this, it's 1 minus lambda A dot A plus lambda times A dot B. And here modulus A, when you multiply 1 minus lambda A dot B plus lambda times B dot B. So I told you you can't consider that A dot B and B dot B is equal to 1 because these are not unit vectors. No? So only simplification you can consider is A dot A is equal to modulus A squared and B dot B is equal to modulus B squared. Now when you multiply this by modulus B, silence katana hai, 1 minus lambda modulus A squared modulus B plus a lambda times modulus B A dot B. And here I get 1 minus lambda modulus A and A dot B plus lambda times modulus A modulus B squared. So when you just simplify, first consider the dot product inside. So here I have considered the dot product inside the square bracket. So here A dot A has been considered, A dot B has been considered. And then B dot A and B dot B has been considered here. Then only I have multiplied the outer one from these two terms. Modulus B has been multiplied by that term and modulus A has been multiplied in that term. So my intention is to subject lambda. No? My intention is to subject lambda. Get this? So here it's when you multiply by 1, modulus A squared modulus B minus lambda modulus A squared modulus B. Okay, this is lambda modulus B A dot B is equal to modulus A dot B modulus A dot B minus lambda times modulus A dot B plus lambda silence modulus A modulus B squared. Okay. Now I want to subject lambda. No? Okay, so I'll take all the terms with lambda to one side, all the terms with lambda to one side. So take this to this side. Modulus A squared modulus B minus modulus A dot B. And take these two terms to the other side, which gives you lambda modulus A modulus B squared minus lambda modulus A dot B. Take these two terms to this side plus lambda modulus A squared modulus B minus lambda modulus B and A dot B. What did I do here? I have taken this to this side and sent these two terms in which are in terms of lambda to the right hand side. So here the only simplification is if you take out a modulus A, that is the only simplification what I see. You get modulus A modulus B minus A dot B. So this is the only simplification what I see here. Okay, here you can take out a lambda, okay, that is the normal thing. Good. So here We have modulus A. Hmm. Okay, look at this. I have taken a lambda out. That is the first step. And then from these two terms, I can see modulus A is common. So when you take out a modulus A, do not, wait, first I'll write this in this way. Let's do in this way. Here, what is common? I'll change these two terms. Terms I'll change these two terms. These two terms I'm just changing. So when you take out lambda out, here I have modulus A modulus B squared. And I'm going to write this one from here, modulus B A dot B. Okay, I have changed these two terms. I'm going to change these two terms, this and this just change in. So here I'm writing minus lambda has been taken out, no, modulus B A dot B and modulus A squared modulus B. This one I'm writing from here, modulus A dot B. Okay, so I have done a small thing. Look at only the thing that I have taken out lambda out, taken out lambda, and I have just changed these two terms. So that's why you have modulus B A dot B, and here you have modulus A dot B. So there is a reason that I have done this. Look at this. There is a reason I have done this. Here I can pull out modulus B common. So when you pull out modulus B common, you get, there's a squared here, modulus A modulus B minus A dot B. So here I have pull out a modulus B that gives me modulus A modulus B minus A dot B. Here I have taken out a modulus A out, which gives me modulus A modulus B minus A dot B minus A dot B. Clear? So here I have pulled out a modulus A out, and here I have put modulus B, and here I have pulled out a modulus A. Now it's clear that this is the same term, no? Modulus A modulus B minus A dot B modulus A modulus B minus A dot B. So same term, you can factorize it. So in the right hand side, I have modulus A modulus B minus A dot B. The right hand side, you can take this common factor out. So it's modulus A modulus B minus A dot B. And when you take that out, modulus B is remaining and modulus A is remaining. Clear? So I have taken out this common factor. So this one, which I have shown using a orange star, it's common. And now it is clear. It is the same factor in the left hand side and the right hand side. Modulus A, modulus B minus A dot B. Which means this is equal to lambda times modulus A plus modulus B. So then lambda is equal to this. Modulus A over modulus A plus modulus B. So you get a clean answer for lambda only in terms of modulus A and modulus B, no any A dot B terms. So a good simplification, do it alone. No? වැරදුනත් කමන්නේ තනියෙන් කරන බෝඩ් එක බලන්න ලස්සනට ලියනවට වඩා වරද්ද තනියෙන් කරන්නේ හොඳයි. Mathematically it's better rather than looking at the board and writing it cleanly. Do the simplification alone. So after this step, I have just taken it out, taken all the lambda terms together and non-lambda terms together. lambda terms together and non-lambda terms together. And here I have just made a small change to make things so it's easier to factorize. And when you factorize, you can see the same factor in the right hand side and the left hand side, so it cancel off. Okay, hands up who got this ones. Okay. One, two. Okay, two are there. Good. Okay, now complete the work. Don't look at the board. To look at the board, only two have taken the answer in the physical class. If anyone in the online class, if you have taken the answers, send me a message. No one from the online class who have taken the answer. Okay, complete the work. Do the simplification and don't get confused with the brackets and the modular sign. So I have shown them clearly. Okay, so let's start some first part vector questions. Start this one, question number 30, 2023. Start this one, 2023 A levels, question number 30. So let's do some first part questions. So these are first part vector questions. Okay, so they have given this position vectors of A and B. OA is equal to 2i plus j. OA is equal to 2i plus j, and OB is equal to 3i minus 4j is equal to 3i minus 4j. Okay. And now look at this. Let C be a point, and they have given a vector equation in this way. 2 times OA plus BC. 2 times OA plus BC is equal to 2 times OC. Okay, 2 times OC. Find OC in terms of I and J, and I'm supposed to find OC. We can now look at this. They have given the two position. You started I said the number 30. No? Okay, never mind. Let's go with the 30th question. It's a second part question. It's not the. I wanted to do the previous question. Never mind. Start. Let's even complete this one. So this is not the first part question. This is the second part question. 2023. Then do question number 30, and then let's do 29. Usual notations, position vectors has been given. Okay, so position vectors means OA, silence, is equal to vector A. It's minus I minus J. And OB is equal to vector B. For I plus 4J, it's I plus 4J. C, the position vector of COC is equal to C, and that is equal to 8I plus alpha J, and OD is equal to D, and it is OI minus 2J. Okay. Then do the find the vectors AB and DC. Show that the two vectors are parallel. Okay, so first thing, show that the lines AB and DC are parallel. So basic stuff, find the two vectors AB and DC. So AB is equal to OB minus OA. So OB is I plus 4J minus OA, it's minus I minus J. So then AB is equal to I plus 4J plus I plus j, I get the vector AB, it's equal to 2I plus 5j. And then DC. Oh no, they have given, no? Yeah. Here lines AB and DC are parallel. So they have given that the two lines are parallel. Given the two lines are parallel and show that alpha equals 8. Okay, then I have taken AB and then I write DC. What is DC? It's OC minus OD. What is OC? It's 8I plus alpha j minus what is OD? It's 4I minus 2j. When you simplify this, you get 8I plus alpha j minus 4I plus 2j. So I get the vector DC is equal to 4I plus alpha plus 2 times j. 4I alpha plus 2 times j. Okay, show that alpha is equal to 8. Show that alpha is equal to 8. Okay, now look at this. I have taken these two vectors, vector AB and vector DC. Now look at this. Now look at this. They have given the two vectors are parallel. Now vector AB and vector DC are parallel to each other. So which means we can express, now look at this closely, there are two ways that you can do this. One way, when you closely look at these two are like they have given the two vectors are parallel. So when the two vectors are parallel, one vector can be written in terms of the other vector. No? One vector can be written in terms of the other vector. Okay, now listen, look at the board. There are two ways that you can do this. One is that you can remember the 2014 question we did. Two vectors are parallel. So then what is DC? DC is 2I plus 5j. Sorry, DC is this, no? DC is 4I plus alpha plus 2 times j, alpha plus 2 times j is equal to lambda AB, and AB is 2I plus 5j. So I have explained every point previously. Like when the two vectors are parallel, I can either write DC is equal to lambda times AB, or I can write AB equals lambda times DC. So, okay, like there are two ways that when the two vectors are parallel, I can either write DC is equal to lambda AB, or AB is equal to lambda DC. But why did I decide to write in this way? If you consider lambda DC, it's clear you get 4 lambda I plus, then you are getting a product between the two constants. No? So I explained this when we were doing the 2014 question. So why did I have decided to take the lambda here? Because AB is just in terms of I and j. So when you multiply it by lambda, there will be only lambda. But if you multiply DC by lambda, then you will be getting a lambda and alpha product, which makes your simplification a bit complex. So that's why I have decided to write this in this way. So when you know you have two vectors, ij, and you have combined them, what you can do, you can take all the vectors to one side, plus alpha j plus 2j, there's another way, a minus 2 lambda I minus 5 lambda j is equal to 0. Then if you consider 4 minus 2 lambda I plus alpha plus 2 minus 5 lambda j is equal to 0. So this is the format. This is in the format of alpha A plus beta B equals 0, which means this coefficient should be equal to 0 and this coefficient should be equal to 0. So when you consider the two coefficients, 4 minus 2 lambda equals 0, which gives you 4 equals 2 lambda, so lambda equals 2, but lambda is not what they're asking. Alpha plus 2 minus 5 lambda equals 0. Lambda is 2. Alpha plus 2 minus 10 equals 0. I get alpha minus 8 equals 0 and alpha equals 8. So this is one way that you can try this one. Clear? So this is, I'll name this as method 1. Same thing that what we discussed under 2014. So that's how you use the experience into a new question. So that is how you use the experience to a new question. They have given two parallel vectors. I have found the two vectors in terms of I and j, and since they are parallel, I have written one vector in terms of the other vector. One vector in terms of the other vector. Even that I have explained previously. Why did I decide to take a lambda here rather than writing the lambda with dc? Because if you go with lambda times dc, you are getting a lambda alpha product. You can simplify, but that makes your simplification a bit complex. So this is one way that you can do this. And I'll explain the other way. A much easier method. Okay, first do in this way. Yeah, I'll use another letter because they have used this lambda later. No? So I'll go with another letter. But inside the question, they have used lambda again. So then there might be a confusion. So I'll go with another letter. Because inside the question, they have used a lambda later. They have used a lambda later. So I'm taking k and this is 5k. Okay, so look at this. What is the other method? Anitya Mukata, look at this. Look at the board. I have taken DC is equal to lambda AB. Now look at this. Look at the board. Again, DC හම්බෙන්නේ when මේ AB lambda එකෙන් වැඩි වුණාම you get DC when AB get multiplied by lambda. Okay. Now look at this. What is AB? It's 2i. Forget about the J. So AB is 2i and in DC that is 4i. So that is 4i. So when you multiply AB by someone, I'll take it K again. So when you multiply AB by someone, this 2i becomes 4i, this 5 becomes alpha plus 2. When you multiply this AB by someone like K, 2 becomes 4, 5 becomes alpha plus 2. Then tell me, to get 4i from 2i, from which number you need to multiply this one? To get 4i or to get 4 out of 2, you need to multiply this by 2. You need to multiply this by 2. Because here 2i is equal to 4i. Then you don't have to go in this way. You can just write in this way. Now it's clear. When we multiply AB by someone, we get this DC. So you can just consider the I. So when you consider the coefficient of I, when you consider the coefficient of I, it's clear that k is equal to 2. K is equal to 2. Which means DC, DC is 4i plus alpha plus 2j is equal to 2 times 2i plus 5j. Same thing. And when you consider the coefficient of j, you get alpha plus 2 is equal to 10, which means alpha is equal to 8. Same thing, but I have reduced the number of steps. Because when you write this in this way and when you consider the coefficient of I, because it's clear here 2I has become 4I. The only possible way to get 2I from, 4I from 2I is when you multiply by 2. So when you compare the coefficient of J, alpha plus 2, that is equal to 10J. Okay. Okay, then do the remaining part. Do the remaining part. Lines AC and BD intersect at E. This one you can do. Lines AC and BD, because they have given the two lines AB and B. Sorry, AB and DC are parallel. AB and DC are parallel. AB and DC are parallel. So this is in this way. The lines AC and BD, wait, the lines, yeah, okay. AC, yeah, AC and BD intersect at E. Find E. E is the position vector of, so you have to find OE. So I'll give 1 in they have considered by considering AE and AC, find OE, position vector. You are supposed to find the position vector of this. So let's say that you have O somewhere here. So how to find that OE? One method is OE can be written as OE can be written as OA plus AE. And it's clear that they have asked you to consider vectors AE and AC. So it's clear you can write OA that you know, and you can write AE in terms of lambda AC. Okay, do it. You can write OE as OA plus AE. So I have considered vector OA plus AE, and AE is equal to this. So next one, write OE in terms of OB plus BE. They have brought a mu there. They have brought a, so then BE can be written as mu BD. Okay, do the work alone and get the two answers. We need to give the answers initially in terms of A, B, C, D. Later only you need that A, B, C. So for now use this is equal to A, this is equal to B. So I'll get this one. So I need you to get the next one. So then vector O, it's E, no? It's equal to A plus lambda AC. How to write lambda AC? IAC can be written as OC minus OA. So why did I decide to take a lambda? Because in the answer, they have introduced a lambda. This is equal to A plus lambda times C minus A. Lambda times C minus A. So then I get vector E is equal to A plus lambda C minus lambda A. And then this is equal 1 minus lambda A plus lambda C. 1 minus lambda A plus lambda C. Okay, similarly get the next one. Considering OBE triangle. So here I have considered the triangle OAE. I have considered the triangle OAE. Now I want you to consider the triangle OBE. Don't look at the board. Board එක බලන්න නෑ මම බලන් ඉන්නේ. So how to take the next one? OE is equal OB plus BE, OB plus BE. OB is vector B and OE, since they have brought a mu here, it's equal to mu times BE can be written as mu BD. Okay. Then vector E is equal to B plus mu. BD is OD minus OB. And then you can write this is equal to B plus mu. This is D minus B. So vector E is equal to mu D minus mu B. So then E is equal to 1 minus mu B plus mu D. Okay. So I have got the two vectors, vector E in terms of A and C, and then in terms of B and D. This is equal to 1 minus mu B plus mu D. Okay, hands up who got the next one for this vector E, this one. Got it. Okay. So then same thing like we did in 2000 and I think 22, 2000, this is 23, no, yeah, 2022 with it, not 22, yeah. Is it 22? Yeah, we got the two vectors in two different ways. So what you can do is to find lambda mu, you can make these two equal. You can make these two equal. When you make them equal, you get 1 minus lambda A plus lambda C is equal to 1 minus mu B plus mu D. Okay, now look at the board because I need you to do this alone. So here, how many vectors do you have? Tell me. How many vectors do you have? Tell me here, how many vectors you have? So you have four different vectors. So what is the theorem we know when we write a vector equation? What is the theorem we know? Alpha A plus beta B equals 0. That means how many vectors are there? How many vectors? Two vectors. So if we have an equation in terms of two vectors, you can separate the two vectors and make the coefficients equal to 0. That is clear. But here you can't do this because there are four vectors. But then we need to understand, even though they have given this in terms of A, B, C, D, all A, B, C, D has been expressed in terms of I and J. So then what you have to do is write all these vectors A, B, C, D in terms of I and J. What is A? That is minus I minus J. What is C? 8I plus 8I plus alpha. Alpha is 8. J. And then we have what is B? 1 minus mu B. Okay, what is B? I plus 4J plus mu D. What is D? It's 4I minus 2J. 4I minus 2J. Okay, now what I want to do, simplify this. Get all the terms to one side. All the terms to one side. Make the coefficient of I and J separately equal to 0. And get the two values, lambda and mu. Okay, do this alone. A good question where many areas has been covered. Do this. Okay, I'll do it because time is going. So multiply minus I minus J minus minus is plus lambda I minus minus plus lambda J plus 8 lambda I 8 lambda J is equal I plus 4J minus mu I minus 4 mu J. 4 mu I minus 2 mu J. So when you simplify this, you get minus I minus J lambda plus this is 9 lambda I 9 lambda j. Bring all this to this side. You have minus I minus 4j minus mu I plus 4 mu I is 3 mu I, which gives you minus 3 mu I. Minus 4 mu j minus 2 gives you, yeah, gives you minus 6, which makes plus 6 mu j. Okay. Okay, then you can, if you take I to one side, minus I is minus 2, 9 lambda, and 3 mu I. And if you take j, minus j minus 4 is minus 5, 9 lambda plus 6 mu j is equal to 0. Don't look at the board, huh? Just do it alone and check whether I have done it correctly. I'm going to make these two equal to 0. So then I have minus 2 plus 9 lambda minus 3 mu is equal to 0. So 9 lambda minus 3 mu is equal to 2. So this is my third equation because I have already used 1 and 2. And the next one will be minus 5 plus 9 lambda plus 6 mu is equal to 0. So 9 lambda plus 6 mu is equal to 5. So 9 lambda is common, so the simplification is easier. 4 minus 3, 9 lambda plus 6 mu minus 9 lambda minus 3 mu is equal to 5 minus 2. Plus 3 mu is equal to 3. So you get 9 mu is equal to 3. So mu is equal to 1 over 3. So I get mu is equal to 1 over 3. Mu is equal to 1 over 3. So even find lambda, even though it's not necessary, but later we need lambda, I'll tell you why. So after getting mu, even find the value of lambda. So I'll go with the fourth one, or the, fourth one. 9 lambda plus 6 mu, 6 mu is this is equal to 5. And then you get, it's the same thing, no? 5 minus 2. So 9 lambda is equal to 3. So even lambda is equal to 1 over 3. Lambda equals 1 over 3. You got these two ones, okay? Okay, answer, we got lambda equals 1 over 3. Mu equals 1 over 3. Good. Okay, then substitute to 1 and get the answer. You're supposed to find the vector OE, no? You're supposed to find the vector OE. You can find this vector E if I go with the first one. Oh, what's the better one? The second one is okay. I'll go with the second one. So then E is equal to 1 minus mu B plus mu D. Yeah, mu is equal to 1 over 3. And what is B? B is I plus 4j. Mu is 1 over 3. And D is 4i minus 2j. So this is 2 over 3. When you multiply, you get over 3i minus 2 over 3j. Okay, multiply, it's 2 over 3i plus 8 over 3j plus 4 over 3i minus 2 over 3j, which gives you 2 plus 4 is 6 over 3i. 8 minus 2 is even 6. So you get E is equal to 2I plus 2J. A nice answer. So vector E is equal to 2I plus 2J. 2I plus 2J. Okay, not done yet. They're asking to find the angle between AED by considering AE and ED. Okay, so find the two vectors EA and ED. So we can do in this. You can now look at this. What is lambda? I have taken, look at this. Lambda is equal, AE is equal to lambda AC. AE is equal to lambda AC. Clear. So here, both what we have got here. Now look at this. I need you to find the vector EA and ED alone. So to how can we get it? AE is equal to lambda AC. And lambda is 1 over 3. No? It's 1 over 3 AC. Which means the line AE is equal to 1/3 of AC. So AE over AC is equal to 1 over 3. So that means you know the ratio. If AE is 1, the entire one is 3, which means so it's 1/3 of this. No? So find EA easily. You can find EA easily. First I'll find AE. First I'll find AE. You don't have to consider this. No, make own it. The next one you want it. Okay, so AE is equal to 1 over 3 AC. 1 over 3 AC, then AC is equal to C minus A. It's equal to C minus A. So what is C? 8I plus 8J minus what is A minus I minus J. So vector AE is equal to 1 over 3 8I plus 8J plus I plus J. This is 1 over 3 9I plus 9J, which gives you vector AE is equal to 3I plus 3J. So they have asked to consider the vector dot product between EA and ED. EA and ED. So I have taken vector EA. It's minus 3I minus 3J. Okay, now I want you to find the vector ED. ED. Find this vector ED. Even this ratio is 1 is to 2. Even this ratio is 1 is to 2. So ED is equal to 2/3 of BD. Find the vector ED. Find the vector ED. Silence, silence. Do the work. Digai have a karana bulu amarune. Find the vector ED. Find this vector ED. Hey, wait, wait. You don't have to wait. I forgot this. We have already taken this vector E, no? We have already taken this vector E, no? Then you don't have to do in that way. Because you have taken this vector E, then you can write vector EA is equal to OA minus OE. That's all. And OA is minus I minus J. A vector, this one is 2I plus 2J. Which means this gives you minus 3I minus 3J. Don't have to go from the beginning. Lambda me won't. And similarly, ED is equal to OD minus OE. What is OD? 4I minus 2J minus 2I plus 2J. So then you have ED is equal to 4I minus 2I is 2I minus 2 is minus 4. See, okay. So it's EA is equal to this. So I have used this vector E. You don't have to go from the beginning. Lambda me won't. So we have the two vectors EA and ED. So take the angle as theta, write the definition and get the angle. Do it alone. Consider the definition of the dot product. I told you when there's something related to the angle, you need to consider the definition between the vector dot product. You can do that. Taniyama gannu. Get this cos theta. Find the value of cos theta. Okay, so they're asking you to consider the dot product between EA and ED. Okay, this is equal to the modulus of EA, modulus of ED, and the angle in between, so cos theta. So I told you when you are supposed to find like anything related to the angle between two vectors, you have to go with the dot product. So what is EA minus 3I minus 3J? What is ED? 2I minus 4J. So here the modulus of this, or modulus of this, times cos theta. So here we know what to multiply, only I dot I and j dot j, which gives you minus 3 into 2 is 6, I dot I, minus 3 into minus 4 is plus, so this is minus 6, plus 12 j dot j. How to take when the vector, how to take the modulus when the vectors are in terms of I and j? Tell me how to take the modulus when the vectors are in terms of I and j. Square of this, square of this, square root, no? Can remember the modulus when the two vectors are in terms of I and j, how to take the modulus, square of this, the square root into 2 squared plus minus 4 squared, square root cos theta, which gives you I dot I is 1, j dot j is even 1. So we have minus 6 plus 12 is equal to 9 plus 9 square root into 4 plus 16 cos. So minus 6 plus 12 is 6 is equal to this is, you can write this as 9 into 2, no? The third thing. And this is root 20 cos theta. So 9, if you take out from the square root, it's 3 root 2. 5 can even written as 4 into 5, sorry, 20 can be written as 4 into 5. So this cancel off. And if you take this 4 out, it's 2 root 5 cos theta. So even 2 cancel off. Root 2 into root 5 is root 10 cos theta. So I get cos theta is equal to 1 over root 10. And you're supposed to find the angle between EA and ED. It's theta equals cos inverse. I explained about this cos, not this inverse thing last week. So when you have to subject this theta, just write it's equal to cos inverse 1 over root 10. So when there's anything related to the angle between two vectors, consider the definition of the vector dot product. You get the angle, and here it's the normal dot product, I dot I, j dot j. If you have the vectors in terms of I and j, how to take the modulus? The square of the coefficient of I plus the square of the coefficient of j. Make sure the square root of that. And I have simplified as much as possible. 9 plus 9 is 18, which is 9 into 2. So 9 can be taken out. Here 4 can be taken out as 2. So this simplifies and give me 1 over root 10. Okay, hands up who got this cos theta equals 1 over root 2 as the simplified. Okay, many are there. Good. Even online class students, if you have got this answer, cos theta equals 1 over root 10, send a message in the chat mentioning you got that one. Okay, complete the work. Let's one last thing and then finish. Okay, write this in a black pen, write note, and in front of that, using a red pen, write this silence. Silence. In a black pen, write note, and using a red pen, write this. Silence, silence. Finding the modulus. Finding the modulus of a vector. Finding the modulus of a vector using write this modulus a squared equals a dot a. Finding the modulus of a vector using modulus a squared equals a dot a. Okay, interesting part. Okay, so this is what we are going to do. Now let's say we have been given modulus a is equal to 2 and modulus b is equal to 3. Okay, and they have given an additional data. The angle between the two vectors a and b is equal to 60. They have given an additional data mentioning that the angle between the two vectors a and b are 5 by 3 or 60. And you need to find the modulus of a plus b. Modulus of a plus b. So when I say, okay, you need to find the modulus of a plus b, the first thing that comes to your mind is, okay, a is equal to 2, b is equal to 3, so we have modulus 5, which is equal to 5. So what did I do? A is equal to 2, b is equal to 3, and you get a plus b modulus is equal to 5. But as I always say, the life is not that easier. And a is not equal to 2. What is equal to 2 is modulus a. So a is a vector. That vector is not equal to 2. So first thing, this is wrong. Where are they? And then what comes to your mind is I'm going to write modulus a plus b is equal to modulus a plus modulus b. I'm going to write this one. And then you write modulus a is equal to 2, modulus b is equal to 3, which means 5. But when we discuss about the modulus of a vector, we didn't learn about something like this. No? We didn't learn that a plus b modulus is equal to modulus a plus modulus b. Not in this class. So even that one, you can't do. I don't give this as the last part of the lesson. No. And put in a note and using this one, where you have to write modulus a plus b is equal to modulus a plus modulus b. Okay. So both are not accepted because I just mentioned that if you feel to do this. So what I'm going to do here is I'm going to use this one. I'm going to use this combination. So what is the modulus that you need to find? The modulus of a plus b. Okay, then I need to find the modulus of a plus b. So then I can write that a plus b modulus squared is equal to a plus b, a plus b. So I'm going to use this one. What is that? The modulus of a vector, the square of the modulus of a vector is equal to the dot product between the same vector. Modulus a squared is equal to a dot a. Modulus A squared is equal to A dot A. Modulus B squared is equal to B dot B. Similarly, A plus B modulus square, the square of this modulus is equal to this vector dot this vector. Is it clear? Hands up if this part is clear. Okay, now using the dot product, I'm simplifying this. A dot A plus A dot B, B dot A plus B dot B plus B dot B. What is A dot A? 1. Tell me, what is A dot A? The square of the modulus A. A dot B, B dot A is commutative 2 times A dot B. What is modulus B? Sorry, B dot B, it's modulus B squared. Okay, now you can use the data. Modulus A squared is equal to 2 squared. That you can use. Okay, you can use that. Plus 2 times, they have given this A dot B. No. Now look at this, they have given the angle between A and B. So there should be a reason that why they are giving the angle between A and B. So I told you, if the angle between two vectors has been given, what is the meaning of that? Tell me. Tell me, if the angle between two vectors has been given, that means we need to consider the definition of the dot product between the two vectors. So here, you can write modulus A, you can write modulus B. What you can't write is A dot B, no. Now how to write A dot B? A dot B is equal to modulus A modulus B cos the angle between the two vectors. So this is the definition of the dot product. Plus, this is 3 squared. Okay, now it's 4, 2 into 2 into 3, cos 60 is half, plus 9, and this cancel off. 4 plus 6 plus 9, you get this is equal to 19. So modulus A plus B squared is equal to 19, which means modulus A plus B, or A plus B modulus is equal to root 90. So this is how you get this, not in this easy methods. So these are wrong. When you are supposed to find the modulus of a vector, like when you have modulus A and modulus B, and the angle between the two vectors have been given, you can find the magnitude or the modulus of any vector which is in terms of A and B. You can find the modulus of any vector which is in terms of A and B. Okay, write in this way. When the modulus of vectors A and B, underline them, when the modulus of vectors A and B have been given, when the modulus of vectors A and B, so it should be ideally moduli, that is okay, modulus of vectors A and B, and the angle between the two vectors, the angle between the two vectors have been given any vector have been given, comma, the modulus of any vector, the modulus of any vector in terms of A, given in terms of A and B, given in terms of A and B, given in terms of A and B can be found in the following manner. Can be found in the following manner. Can be found in the following manner. Is that sentence correct? I have mentioned the modulus of any vector given in terms of A and B can be found. No? So the modulus can be found. It makes sense? No? Okay. Then write the question. Write the question. Put Q and write the question. If modulus A, look at the board. If modulus A equals 2, modulus B equals 3, modulus B equals 3, and the angle between A and B is 5 by 3 is 5 by 3 is 5 by 3. Find find not the comma, okay, find comma. Then write these four, 1, 2, 3, 4. I have done the first one. After doing the first one, do the second one, and the remaining two you can do at home. Write the 4, modulus A plus B, 3A plus 2B, A minus 2B, and 2A minus 5B. First one, you can get the help from the board. Second one, do alone, and 3 and 4 you can do at home. The same way you have done the trigonometry homework. Okay, so I'll take the second one. Silence. So second one, so we need 3A plus 2B squared. So then you have to consider 3A plus 2B dot silence 3A plus 2B. So here when you multiply, it's 9 A dot A are 6 A dot B and 6 B dot A plus 4 times B dot B. Same thing, only the coefficients change. So A dot A is modulus A squared, and here we have, because of the commutative thing, it's 12 A dot B, and it's 4 B squared. And here we know this is equal to 2. Then apply the definition, cos 60 4 times, and this is 3 squared. You get 9 into 4, 12 into 2 into 3, cos 60 is half. Silence. Okay, so these two cancel off. So it's same, no? 4 into 9 into 4 and 4 into 9, yeah. 36 plus 36 plus 36. So then you have 3A plus 2B. I know when you add this, it's 108, but better to write it in this way, so then you can easily keep answer, a simplified answer. This is equal to 36 into 3 square root, which means modulus 3A plus 2B is equal to 6 times root 3. 6 times root 3. Okay. So even though when you add this and get it as 108 root, same thing, 36 into 3, 6 root 3. Okay, hands up who got the second one, 6 root 3. Okay, then you can get ready to go. Keep the trigonometry homework out. Keep it out and you can pack your bags. Okay. Okay, so next week, silence. Okay, after completing this, next week we will be starting second part of trigonometry. No. Okay. So next part we'll be starting the second part of trigonometry. Second part, listen, pack your bags, but don't make it noise. So second part consists of mainly 5 sections: sine theorem, cos theorem, trigonometric inverse functions, general solutions, and trigonometric graphs. Out of those five, in December, we'll be doing two, the sine theorem and the cos theorem, and the remaining three will be done in February. So even tomorrow, most probably tomorrow or Monday, I'll be sorry, not tomorrow. Means yeah, not this is not Saturday, no. So most probably by Friday, I'll be uploading a second tute for the homework as the homework of trigonometry. So I'm doing this on like for your benefit. Then when we start the second part, when we are doing the simplification, you won't find the trigonometric all these formulas hard. If not, like some of the students, like they might think these are new stuff. Sin A plus B can't remember how to write, so that you can't do in that way. So that's why I'm doing this all for your benefit. So make sure you do the homework. And now when I ask you to come, first girls come, bring the homework. And even if we haven't done, just come and tell me only just one warning from this Kane. That's what Bangano. You will see today. And I thought that you won't come without doing homework. එකපාරක් ගෙහුවම ඇති. Okay. Okay, so online students make sure you do. I can't send a cane through online. Courier කරන්න බෑ. So make sure you do the homework properly, and next week we'll start in trigonometry. Okay, first quickly the girls come and then the boys come. Hey, what about me? පිටිපස්සෙන් පයින්නවද කියලා? Okay, quickly come. Bring the homework that you have brought.